Assalamualaikum. Fahad Hassan, registration number 16TE10. Today the topic of our it is week 14A, IIR filter design. Objective: design such a filter whose response infinite impulse. Now giving a brief introduction about IIR filter design means infinite impulse response filter design. In this infinite impulse response filter, we see current as well as previous value of output, means current value and previous value of output both will count. Why IIR filters are preferred? Element of feedback includes by using infinite impulse response filter, and one can improve the output. Number second point is reduces computational cost because the number of filter coefficients is less and can be stable or unstable. Now bilinear transformation design method, following are the steps. First of all, the digital filter specifications are given. We have to find out the analog filter specifications. This step is done through transformation with frequency warping, and from analog filter specification we have to calculate the analog filter transfer function, and this is done through transformation by low pass prototype filter, and in the final step we get the digital filter, and from analog filter transfer function we get digital filter transfer function. This is done through bilinear transform. Now analog low pass prototype transformation. If we are given analog low pass prototype filter and we are asked to design a low pass filter, digital filter, so we have to replace S with S over omega A. Similarly for high pass we have to replace analog low pass prototype means HP of S, where S will be replaced with omega A by S, and in band pass we have to replace S by S squared plus omega naught squared, where omega naught equal to under root omega low and omega high both product, and capital W is the bandwidth, omega high minus omega low, and for band stop we have to simply take the reciprocal of band pass. Now solving example 8.6 of our textbook, we were given a low pass filter which with the prototype as 1 over S plus 1. The cutoff frequency was 15 Hz. We had to design a digital infinite impulse low pass filter using bilinear transformation. Sampling rate was 90, sampling frequency was 90 Hz, and sampling rate is calculated as 1 over Fs, so 1 over 90 seconds. So first step is to calculate the digital frequencies. The formula to calculate digital frequency is 2 pi f, where f is the cutoff frequency which was given. So we will get the answer. Second step, we have to do the frequency warping. For that there is formula 2 by t tan omega dt by 2. Simply we have to put all the values and we will get the frequency warped, analog frequency warped frequencies. So, and in the next step we have to replace the prototype denominator term, where S is coming with S over omega A, and we will get, after performing the algebra, H of S we will get. And in the final step we have to apply bilinear transformation. Now we are going towards the Z domain, so we will replace h of s, where s is replaced with 2 by t z minus 1 over z plus 1. Again, simply replace s with 2 by t, z minus 1 over z plus 1, and after doing the required algebra, we will get h of z in the following form. Now what can we conclude is that by using the similar step, that is calculating the digital frequency, then analog frequency, warped frequencies, and replacing the prototype with s equal to s over omega a, and in the final step applying bilinear transformation to get the transfer function of digital filter. That is done simply by replacing s with 2 by t z minus 1 over z plus 1. We can similarly design high pass, band stop, and band pass filters. What we have to do, because here we had to design low pass filter, so we replaced prototype with s equal to s over omega a. If we had to design high pass, we would replace prototype s with s omega a over s. Simply we have to do this alteration, and the remaining steps are always same. Thank you for watching.